Hi everyone, and welcome to our video on an exponential equation problem where they just straight up give us the exponential equation. So we keep seeing different scenarios where we have to usually figure it out, but this time they give it to us. So let's see what they want. So it says a car's estimated value V of t in dollars after t years is given by this. What did the car cost originally? Okay, so now it's just making us break down this equation. Remember that whatever this is, whatever that number is an initial amount. So that's what this car cost initially or originally. Okay, so that's all we had to do there is just dissect that information. Done. And then also let's also get some arrows going. So this is the estimated value after t years. So this is an amount after t years. And then that it's negative, so we would say that that's a decay rate, and then t is time. Okay, so just a fresh reminder of those vocabulary. All right, so let's see this. What is the car's value after 5 years? So they're just saying let t equal 5 in our function up there. So we've got v of 5 is equal to 25,000 e to the negative 0.25 times 5. Okay, and so we'll need our calculator on this as well. Let's plug that in. I've got Desmos ready, so we've got 25,000 e to the negative, let me use parentheses again, negative 0.25 times 5. $7,000. Okay, let's round it to the nearest cent. So $7,162.62. Okay, so I want to get that first. So V of 5 equals that. Okay, so after 5 years, it's about $7,000, or it's worth about $7,000. Okay, and if you own a car, if you know about this, so this is depreciation. Okay, so cars, they go down in value very quickly. So this looks like it probably makes sense. Okay, so a lot of money lost if we're trying to sell it after 5 years. Okay, so depreciation can be a bummer. All right, anyway, let's see what else we got. Let's find the rate of change. Let's keep that there. Find the rate of change. Remember, rate of change is telling us we will do a derivative of the car's value after 5 years and explain its meaning. Okay, so first thing, let's just rewrite the original function. So v of t equals 25,000 e to the negative 0.25 t. And then we'll do our derivative. So we have v prime of t. Remember, the derivative of an exponential is itself, so 25,000 e to the negative 0.25 t, and then times the derivative of the power, which just requires the power rule, which does give us negative 0.25. Okay, and now I'm going to plug in 5. So we have 25,000 e to the negative 0.25 times 5 up there in the power, and then after all that's done, we'll multiply it by negative 0.25. Okay, so back to the calculator. Notice I already have this part, and I just need to multiply it by a negative 0.25 after. There we go. Okay, so we get, it's a negative value. It's negative $1,790.65. So v prime of 5 is negative, let me double check that, $1,790.65. Okay, and it's a negative. Okay, so, but it's a derivative, so this makes sense because this is saying the car's value is decreasing. Okay, so we've got the car's value is decreasing at a rate of $1,790.65 per year after 5 years. Okay, so because they did t equals 5, so after that amount. Okay, so that's it. So we can see, oh yeah, it's going down by about $2,000, rounding up a lot, after about that time has passed. Okay, anyway, that's it. Okay, so it ends nicer than it began, I think. So either way, growth and decay, you get something like this. Sometimes we need to figure it out, and it could be a little harder. But here, I guess they're taking it easy on us as it ends. But that's it. So thank you for watching. If you have any questions, please let me know.